Imagine taking a test where the only way to pass is to constantly peek at the answer key. This paradox defines the current state of deep subspace clustering. While it claims to be unsupervised, most methods still secretly rely on labeled data to work. This paper introduces a truly autonomous solution. The core problem is that purportedly unsupervised algorithms are actually cheating. They rely on ground truth labels to tune hyperparameters and determine when to stop training, effectively breaking the promise of autonomy. Furthermore, they often discard valuable structural data by focusing only on the final output layer of the network. To fix this, the researchers completely favor a sequential approach over the traditional balancing act. Instead of manually weighing conflicting loss functions, which requires human intuition or labels, this new framework optimizes specific objectives one after another, eliminating the need for sensitive hyperparameters. A key innovation here is the joint representation strategy. Rather than just looking at the network's final output, the authors force a single representation matrix to be shared across every layer of the encoder. This constrains the model to find a robust global structure that holds true from the input all the way down to the bottleneck. This diagram visualizes the two-stage sequential workflow that replaces hyperparameter tuning. First, the model undergoes pre-training to learn basic features, and then it moves to a fine-tuning stage that optimizes clustering quality directly. This separation is what allows the system to remain stable without manual intervention. True autonomy also requires knowing when to stop. The researchers introduced a self-stopping mechanism based on relative error. The model simply watches its own affinity matrix, and when the changes between epochs stabilize below a set threshold, it creates the final clusters, no external supervision required. The results validate this rigorous approach. The proposed method not only consistently outperformed standard linear algorithms, but also matched the accuracy of Oracle deep learning methods that cheat by using labels for tuning. This proves we don't need to sacrifice performance to achieve true unsupervised autonomy. By enforcing joint representation and sequential learning, this work essentially frees deep subspace clustering from its dependency on human oversight. For more deep dives into autonomous AI research, head over to emergentmind.com.